Alright, we have 1-4 functions as our section for today. First thing that we're going to take a look at is the definition of the function, and just a reminder that a function has one output for every input. So if I had 1 turning into 3, that's fine, but I can't also have 2 turning into 3 and 5. So 1 and 2 turning into 3, that's perfectly fine. 2 turning into 3 and 5, that is not allowed. So you can have more than one input turning into a single output, but every input can only have one output. I think one way that I think about this is if we look at all the students in the classroom and ask them to take the money out of their pockets, right? Student 1, student 2, student 3 might have $1 in their pocket, might have $5 in their pocket. The third person might also have $5. It's okay for the answers to repeat, but what wouldn't be okay is if student 4 said, hey, I've got $5 in my pocket and at the same time I have $1 in my pocket. Doesn't make sense to have two separate answers for each student. Alright, so sorry about this. Get rid of the line. In your textbook here, it's just defining each of the points. What we just talked about, each element in A must be matched with an element in B. So every input has to at least have one output. Every single student has to have some value, even if it's 0. You can't have a student that doesn't have an answer. Some elements in B may not be matched with any element in A. So it's okay for you to have answers like, hey, does anybody have $3 in their pocket? Nope, nobody does. That's fine. And again, 3 and 4 are just talking about how we have to match up. And so 1, 2, 3, and 4 different ways we can represent a function. Verbally by a sentence. Every input has one output, so like every student has an amount of money in their pocket. Numerically, a table or a list. So we could have a t-table, x and y. For every input, we have an output. Graphically, points on a line. And let's remember that we have to pass our vertical line test. So that would be a function, but this, sorry, pen tool's not working. This would not be a function. Okay? And algebraically by an equation in two variables, this is what we're typically looking at, y equals 5x. And we do have our function form, f of x instead of y equals 5x. Alright, so let's try an example. Determine whether the relationship represents y as a function of x. For A, the input value, x is the number of representatives from a state. So for problem A, let's make a little chart. We've got our reps, and we have our senators. Alright, so this is possibly a function, possibly no, this is a function because the answer has to be 2. There's only 2 senators in every single state, so maybe California has, I'm not sure how many reps it has. Let's call it 50. And maybe a small state like Rhode Island only has 3, but every input has 1 output, even if the outputs are all 2. Let's look at B. The input and the output right away. This is not going to be a function because the number 2 matches up with 11, and down here 2 is also matching up with 10. Cannot have 2 outputs for a single input. And C does pass our vertical line test. So it is a function. Alright, so try to take a look at this for yourself. Exercise 11. Alright, if you're ready to check out the answer, is this or is this not a function? Does every input have its own output? Yes, it does. There is no repeating going on. -2 just turns into 8. There is no -2 anywhere else. Another way to think about it, are there any repeats in the x's? No, there's not, so this is a function. Alright, example 2, testing for functions represented algebraically. Which of the equation represents y as a function of x? So, to do this, let's get y all by itself. And so y1 minus x squared, there is only one value for every x squared. We have y all by itself. Don't know why that went away. Bring it back. Minus x squared, y equals 1 minus x squared. And so there is only one value for y for every single x. Whatever you plug in for x, we get a single value for y. So this is a function. For b, let's get y by itself again. Y squared equals 1 plus x. And if we were to finish this off, we would take the square root. And remember, whenever you take the square root, you get a positive and a negative answer. So here, for every single y, we could have a positive and a negative. Two separate answers. So this is not a function. Go ahead and give this a shot for yourself. Exercise 21. Alright, if you're ready for your answer, let's take a look. On 21, we're going to get y by itself.